On the next series of slides, I'm going to talk in depth about two fundamentally different graphics formats, raster and vector. First, we'll cover the raster format. So here are some examples of raster graphics, also known as bitmap graphics. You can see that some have a kind of photographic look and feel. Photographs by nature are raster graphics. Going counterclockwise from the top, we see examples of raster graphics that go from pure photographs to less resembling photographs and more synthetic. Raster graphics could be synthetic ones like the fish and coffee cup that are created from scratch by an artist, but nevertheless, they have a kind of painted rather than drawn look with a lot of detail. The fish could actually be created as a complex vector graphic due to its fairly crisp, clean lines and borders, but it was created with raster graphics tools. The slide background and headings in this whole sequence of slides are raster graphics as well. Here are the defining characteristics of raster graphics. Why is it important to know how to distinguish raster from vector graphics? Because the software tools for creating and editing them are different. You wouldn't want to try to hammer nails with a screwdriver. Raster graphics are composed of a grid of colored pixels. On the right is a blow-up of this little smiley face, showing the color components of individual pixels. As you learned previously in the course, each of these pixels is composed of a red, green, and a blue dot on a display. In print, they are composed of cyan, magenta, yellow, and black dots. Most raster images are what they call continuous tone images, meaning that you can represent subtle and complex patterns of color that flow continuously into each other. From one pixel to the next, there could be a slightly different color. Raster is not only the best, but really the only graphics format you can use for photographs or digital paintings. But raster graphics are resolution dependent. They have a fixed resolution to start out with. The quality of the image is limited by this. We'll get more into this in a minute. So here's a raster image, a photograph actually, at different levels of magnification, 3:1 and 24:1. You can see the individual pixels starting to appear at 3:1 zoom level, and you can definitely see the individual pixels in the 24:1 zoom. Raster graphics files, as you saw in the last slide, contain a grid or table of pixels, each having a distinct color value like you see here. When you zoom into a raster image, you start seeing the grid. If you looked at the code for this file, you would see that it is a table of color values. It starts at the upper top left and goes across each row, saying the first pixel is this color, the second pixel is this color, etc., etc. Again, it's simply a database of color values. Each of these values is a pixel. By contrast, this is an example of a vector graphic. It's the same bicycle, but you can tell it's a synthetic drawing. It's a very high-quality drawing, but it's still a drawing, not a photograph. In the graphics industry, vector graphics like this are called artwork rather than images. Images is the term used for raster graphics. This artwork was done in Adobe Illustrator, which is the main vector graphics software program. The previous one was done in Adobe Photoshop, which is the main raster graphics program. In this graphic, you can see how things resolve very cleanly at any level of magnification. The reason for this is that vector graphics are defined using geometry. There's a geometric formula defining each part of this graphic that Adobe Illustrator creates behind the scenes and tells the computer, for instance, draw a circle with a radius of 10 with a certain color. It's all done with math. Every time you magnify part of the graphic, the formula recomputes and you get a clean, crisp result. Raster graphics, on the other hand, are simply a grid of pixels, with each pixel having a color value. It's effectively a database of color values. There is no geometry or math involved with raster images. It's just a database with fixed values. The reason why vector graphics are scalable with no loss of quality is because all you're doing behind the scenes is putting some numbers in math formulas and letting the computer figure out how to draw it at the best quality it possibly can muster, given the pixel density of the display. It's doing this each time you rescale it. Here's an illustration of the concept of the bounding box in raster graphics and the lack of rectangular bounding box in vector graphics. By nature, each raster graphic has a rectangular bounding box. That's the nature of the beast. It's a grid of pixels, and that is inherently a rectangle. You may not see the rectangular bounding box if there's an alpha channel applied to the background. In this case, the alpha channel designates all of the white background pixels as transparent. The bounding box is still there. It and the background is just not visible because it's been knocked out temporarily by the alpha channel. Now you see the vector graphic with the individual objects highlighted with different colored lines. This is what the vector graphic looks like in Adobe Illustrator when you've selected all the objects in the graphic. Note how each object has a distinct edge or border. There is no rectangular bounding box for the whole graphic or any of its individual objects. You can imagine how easy it is to manipulate these vector objects individually, since they are by nature separate from everything else in the graphic. In the raster world, editing individual objects relies on each one of them being in a different layer. Isolating the objects in a photograph into separate layers is not easy, and often does not achieve a very good result. There is a whole software industry built around masking or separating objects in raster images into layers. This slide also shows how a graphic can appear exactly the same as a raster or vector graphic. This is because you can easily convert or rasterize a vector graphic. In fact, that is what your display is doing on the fly when it renders any vector graphic onto your screen. The geometric formulas in the vector graphic code have to be computed and output as pixels in order to display on your screen. However, the reverse, which is vectorizing a raster graphic, is much more difficult and usually gives you unacceptable quality results, especially for photographs. You'll see an example of this in a later slide. In spite of how good the vector format sounds, the raster format has some distinct and important advantages. The most important advantage is that it's the only format that can be used for photographs, like the dimmed out one used in the background of this slide. A photograph is by its very nature a raster image. The raster format is also the only format that works for digital paintings, and in general, continuous tone images with rough edges, textures, and gradations of color. This last item is changing fast. There are now features in programs like Illustrator that do allow you to do some of those things, but they often look synthetic, not naturalistic. The raster format allows you to have control over individual pixels. The vector format doesn't do that, since you're working with math formulas behind the scenes, not pixels. Many special effects are available only for raster images. If you create a vector graphic in Illustrator, you often have to convert it to a raster image in order to use the special effects, like applying a stained glass or oil paint look. Most web and animation formats are raster. This is slightly less true than it used to be, but still, you're mostly limited to SVG for vector graphics on web pages. All the other file formats are raster formats. If you've been getting excited about the raster format up to now, I hate to disappoint you because, like anything, it has some significant disadvantages over the vector format. The most important one is that the raster format is resolution dependent. We'll get into that more in detail in a minute, but what it means in a practical sense is that the quality and editing options depend on the original file resolution, or as I've been calling resolution, the combination of pixel dimensions, pixel density, and physical size. If you do not work carefully within the resolution constraints of an image, you'll get pixelation, which is where you start actually seeing the image as blurry or blocky. The editability of a raster file depends on masking out backgrounds from foregrounds and putting these in separate layers. This is a time-consuming and awkward process. In the vector world, each element in the image is inherently separate and can be manipulated separately right out of the starting gate. The options for manipulating type are more limited in raster graphics tools. This is primarily because type characters themselves are vector objects and can be more easily manipulated as such. The file sizes for raster graphics are inherently much larger, simply because every pixel in the image has to have a color number specified for it, whereas in vector graphics, math formulas that could be only a few lines of code sit behind the scenes to specify parameters for objects in the artwork. I wouldn't say it's hard to create crisp, clean lines in raster programs, but that is definitely easier to do in vector programs. Again, because geometry is at work behind the scenes to create perfect curves and lines. Photo compositions using live models and sets, unless you're using high-end landscape creation and 3D modeling software, are more expensive than creating from scratch in a vector program. This is not an equivalency, of course, because on the one hand you're creating photographically realistic images, and on the other, synthetic-looking images. Those are two totally different styles. Here are a few of the most popular raster formats for web and print. I'll cover these in later slides in this unit. They're not mutually exclusive, except perhaps in the case of GIF, which is far too limiting to use for printing, especially commercial printing. Here are some of the most common raster graphics creation and editing tools.